Look up at the night sky. Every tiny point of light you see is a star, and many of those stars have planets. Scientists now know that planets are incredibly common throughout our galaxy, and some may even be similar to Earth. Imagine this: there are hundreds of billions of stars in the Milky Way alone, and hundreds of billions of galaxies in the observable universe. With numbers this enormous, many scientists think it is likely that life has arisen somewhere else. Maybe not just simple life, but intelligent civilizations. So why haven't we found clear evidence of them? No confirmed signals, no confirmed spacecraft, no confirmed contact. This simple but profound question is known as the Fermi Paradox. Paradox is named after physicist Enrico Fermi. In 1950, during a casual conversation, he reportedly asked a simple question: where is everybody? It wasn't meant as science fiction, it was a scientific puzzle. If intelligent civilizations are likely to exist, why don't we see convincing evidence of them? That single question inspired decades of research and debate, leading scientists to explore the possibilities of life beyond Earth and the reasons why we might not have detected it yet. Fermi's question continues to challenge our understanding of the universe and our place within it. The observable universe is unimaginably vast. Our galaxy alone contains hundreds of billions of stars, each potentially hosting its own planetary systems. Astronomers have discovered thousands of planets orbiting other stars, and the numbers keep growing as technology improves. This vastness means that the probability of life existing somewhere else seems high. Yet, despite our best efforts, we have not found definitive evidence of extraterrestrial civilization. The sheer scale of the universe makes the search for life both exciting and daunting, raising questions about our methods and the limitations of our technology. Recent discoveries have shown that planets are not rare at all. In fact, most stars are believed to have at least one planet orbiting them. Some of these planets are located in the so-called habitable zone, where conditions might allow for liquid water and potentially life. The abundance of planets increases the likelihood that life could exist elsewhere. With so many possibilities, scientists are optimistic about finding signs of life, but the challenge remains in detecting it across such vast distances. One of the main ways scientists search for extraterrestrial intelligence is by listening for signals. Radio telescopes scan the skies for patterns that might indicate artificial origins. Despite decades of searching, no confirmed signals have been detected. This silence is puzzling given the vast number of stars and planets. It raises questions about whether civilizations are rare, short-lived, or simply not broadcasting in ways we can detect. Another approach is to look for physical evidence, such as spacecraft or probes. So far, no confirmed sightings of alien technology have been reported. This absence is surprising, considering the possibility that advanced civilizations could travel or send probes across the galaxy. The lack of evidence suggests either that such civilizations do not exist, are not interested in exploration, or are extremely good at hiding. Fermi Paradox is the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations. It challenges our assumptions about life, intelligence, and the universe. Scientists continue to debate possible explanations, ranging from technological limitations to the possibility that civilizations self-destruct before becoming detectable. Given the vast number of planets, the probability that life exists elsewhere seems high. Scientists use mathematical models to estimate how many civilizations might exist. These models take into account factors like the number of stars, the likelihood of planets, and the chances of life developing. Despite optimistic estimates, the lack of evidence remains a mystery. Drake equation is a famous formula used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. It considers factors such as the rate of star formation, the fraction of stars with planets, and the likelihood of life and intelligence. While the equation provides a framework, many of its variables are still uncertain, making predictions challenging. Some scientists propose the rare Earth hypothesis, which suggests that complex life is extremely rare due to a combination of unique planetary and environmental factors. Earth may have benefited from a series of fortunate events, such as a stable climate, protective magnetic field, and the right chemical ingredients. This hypothesis implies that intelligent life may be much less common than previously thought. Great filter theory suggests that there is a stage in the development of life that is extremely difficult to pass. This filter could occur at any point, from the emergence of life to the development of intelligence or advanced technology. If the filter is ahead of us, it may explain why we haven't found other civilizations. If it's behind us, it could mean we are rare survivors. Another possibility is that civilizations tend to self-destruct before they can communicate or travel across the galaxy. This could be due to war, environmental collapse, or technological mishaps. If self-destruction is common, it would explain the silence we observe. It also serves as a warning for humanity to avoid similar pitfalls. Our technology may simply not be advanced enough to detect alien civilizations. Signals could be too weak or use methods we haven't discovered yet. It's possible that we are missing evidence because we don't know what to look for. As technology improves, our chances of finding signs of life may increase. Even if civilizations exist, communication may be difficult. Signals could take thousands of years to travel across space, or civilizations may use methods we don't understand. Language barriers, different technologies, and vast distances all make contact challenging. These obstacles may explain why we haven't received any messages. The lifespan of civilizations may be short. If intelligent life tends to destroy itself or fade away, the chances of overlapping with another civilization are low. This could mean that civilizations rarely exist at the same time, making contact unlikely. The question of longevity is central to understanding the Fermi paradox. Some theories suggest that advanced civilizations may deliberately hide their presence. This could be for safety, avoiding detection by hostile species, or simply a preference for privacy. If civilizations are hiding, it would explain the lack of evidence and signals. The idea of hidden civilizations adds another layer to the mystery. The zoo hypothesis proposes that advanced civilizations observe us without interfering, much like humans observe animals in a zoo. They may be waiting for us to reach a certain level of development before making contact. This theory suggests that we are not alone but are being watched from afar. Some believe that advanced civilizations follow a principle of non-interference, avoiding contact with less developed species. This could be a moral or ethical decision, similar to how humans avoid disturbing isolated tribes. If this principle is widespread, it would explain the lack of evidence and contact. Life elsewhere may be fundamentally different from what we expect. It could be based on different chemistry, exist in extreme environments, or be non-biological. If alien life is unlike anything we know, it may be difficult to detect or recognize. This possibility expands our understanding of what life could be. If civilizations are capable of colonizing the galaxy, we might expect to see evidence of their expansion. However, no signs of large-scale colonization have been found. This absence could mean that colonization is rare, difficult, or not pursued by advanced civilizations. The question of galactic colonization remains open. The energy required to travel or communicate across the galaxy is immense. Civilizations may be limited by their ability to harness and use energy efficiently. This limitation could restrict their activities and make detection harder. Energy constraints are a significant factor in the search for extraterrestrial life. The speed of light is a fundamental limit in the universe. Communication and travel are restricted by this barrier, making interstellar contact slow and difficult. Even if civilizations exist, the time required for signals or spacecraft to reach us could be longer than the lifespan of a civilization. The vast distances between stars and galaxies create a sense of cosmic isolation. Even if life exists elsewhere, the chances of interaction are low due to the immense space separating us. This isolation may be a fundamental reason for the Fermi paradox. Signals sent across vast distances may degrade or become lost in cosmic noise. This makes detection challenging even if civilizations are broadcasting. The problem of signal degradation is a technical hurdle in the search for extraterrestrial intelligence. The search for extraterrestrial intelligence (SETI) is an ongoing effort to detect signals from alien civilizations. SETI uses radio telescopes and other technologies to scan the skies. While no confirmed signals have been found, the search continues, driven by curiosity and the hope of discovery. The discovery of exoplanets has revolutionized our understanding of the universe. Thousands of planets have been found orbiting other stars, some in the habitable zone. These discoveries increase the chances of finding life and provide new targets for exploration. Astrobiology is the study of life in the universe. Advances in this field help us understand the conditions necessary for life and guide the search for extraterrestrial organisms. Astrobiologists explore extreme environments on Earth to learn how life might survive elsewhere. Mars is a prime target in the search for life. Robotic missions have explored its surface, searching for signs of past or present life. While no definitive evidence has been found, Mars remains a focus for future exploration and research. Moons like Europa and Enceladus are considered promising places to search for life. They have subsurface oceans that could harbor organisms. Future missions aim to explore these moons and analyze their environments for signs of life. Understanding how life originated on Earth helps guide the search for life elsewhere. Scientists study ancient rocks, chemical processes, and extreme environments to learn about the conditions that led to life. These insights inform the search for similar conditions on other planets. Extremophiles are organisms that thrive in harsh environments such as deep oceans, hot springs, or frozen tundras. Their existence shows that life can survive under extreme conditions, expanding the possibilities for life elsewhere in the universe. Occasionally, scientists detect unusual signals from space. While most are explained by natural phenomena or human activity, some remain mysterious. These rare signals fuel speculation about extraterrestrial intelligence, but none have been confirmed. The WOW signal is a famous unexplained radio signal detected in 1977. It lasted for just a few minutes and has never been repeated. While intriguing, it remains a mystery and has not been confirmed as evidence of extraterrestrial intelligence. Tabby's star is another astronomical mystery. Its unusual dimming patterns led some to speculate about alien megastructures, but natural explanations are more likely. The star remains a subject of study and debate. The idea of alien megastructures such as Dyson spheres captures the imagination. These structures would harness the energy of stars and could be detectable by their effects on starlight. So far, no evidence of such megastructures has been found. Artificial intelligence may play a role in the search for extraterrestrial life. AI can analyze vast amounts of data, identify patterns, and help detect unusual signals. As technology advances, AI will become increasingly important in the search for alien civilizations. Our search for extraterrestrial life is influenced by human bias. We tend to look for life as we know it, using familiar methods and assumptions. This bias may limit our ability to detect or recognize alien civilizations that are fundamentally different. The Fermi Paradox raises profound philosophical questions about our place in the universe. Are we alone? What does it mean if we are? The search for extraterrestrial life challenges our understanding of existence and inspires curiosity about the unknown. The idea of extraterrestrial life has a significant cultural impact. It influences science fiction, art, and public imagination. The Fermi Paradox is a popular topic in media and inspires ongoing debate about the possibilities of life beyond Earth. Future missions and technologies will continue to expand our search for extraterrestrial life. New telescopes, probes, and AI tools will improve our ability to detect signals and analyze distant worlds. The quest for answers is ongoing and full of promise. The search for extraterrestrial life is a global effort. Scientists from around the world collaborate, sharing data and resources. International partnerships enhance the search and increase the chances of discovery. Public interest in the search for extraterrestrial life is strong. Citizen science projects, educational programs, and media coverage encourage engagement and support. The quest for answers is not just scientific, but also a shared human adventure. The search for extraterrestrial life raises ethical questions. How should we respond if we find evidence? What responsibilities do we have? Scientists and philosophers debate the best approaches to contact and communication. The Fermi Paradox remains one of the greatest mysteries in science. Despite the high probability of life elsewhere, the lack of evidence challenges our understanding. Scientists continue to explore explanations, search for signals, and expand our knowledge of the universe. As we look to the future, the search for extraterrestrial life continues to inspire curiosity and innovation. New discoveries may one day solve the Fermi Paradox or reveal even deeper mysteries. The journey is ongoing and the universe awaits our exploration.